Hey everyone, and welcome to the Magic Show. For my next trick, I'm just kidding, but I do want to tell you about how we at T-Mobile used an edge gateway to sort of make our platforms disappear. Now, before we get into the cool stuff, I'll start by introducing myself. My name's Joe Searcy, and I'm not actually a magician at all, but I am an engineer at T-Mobile where I try to build neat things with containers to make technology simple for others. I've been working in and around the Kubernetes project for the last 5 years or so, and I've been trying to make Kubernetes as simple as possible for our development teams at T-Mobile to consume. I have the privilege of working with some truly amazing engineers that I get to learn from and build cool stuff with on a daily basis. I want to kick off this story with talking through how we came to need an edge gateway. I feel like the why is almost as important as the how. As most enterprise companies, we were continuing to strive for ever better resiliency amongst the services that we offer at T-Mobile. And we got to a point where we started to see some patterns starting to emerge. And I don't mean the good kind of patterns here. It became obvious that resiliency was sort of tough for a lot of our teams. And this seemed really odd to those of us on the platform side of the house because we felt like we had done a really great job designing the platforms themselves to be resilient, making sure that the platforms had multiple availability zones, that we had the platforms available to developers across multiple data centers and multiple public cloud providers. But that didn't really solve the problem of how do I route traffic across multiple geographically dispersed platform instances? You know, sort of in simplistic terms, how do I route traffic across multiple Kubernetes clusters in different regions? And we started to dig in and do a bit of investigation that ultimately led us to discover a number of problems that our development teams were really struggling with. The problems that we found ran a lot deeper than we expected. It wasn't really just an issue with routing traffic across multiple Kubernetes clusters. It was a little more systemic than that. We discovered that the job of building resilient services was not only difficult to begin with, but our platform sprawl had actually added to the challenges. Our developers, being ever resourceful as always, were going out and solving a lot of these problems themselves. But that meant a lot of time dedicated to non-functional requirements instead of business logic. We started gathering a good amount of data to help us decide on a path forward and found some sort of disturbing information, if you will. Some of the most disturbing was that 25% of developer time was spent on non-functional requirements. That's a lot of time spent not writing code. But even more disturbing was that we discovered 75% of production issues were due to networking and configuration problems. Let that sink in for a second. At this point, we were kind of worried, and we had to discover where all this time was being spent. So we started mapping out the different traffic routing solutions that we discovered across various pieces of the business. Some of them being managed by infrastructure teams, some managed by platform teams, some managed by different development teams. Overall, there were lots of patterns, lots of opinions, and lots of inconsistency. That all added together to be a lot of money and time being wasted. And that didn't make us feel better at all. There were just too many solutions, and that added to sort of the stress and difficulty that developers face when starting out with a new application. Each solution seemed to be managed by a different group with different levels of grassroots adoption. There were tons of overlapping features between the different solutions, and the development teams seemed to be owning the life cycles of these solutions. So yet again, more time spent not focusing on code. Security solutions were sort of all over the place, but overall, we didn't really have any sort of centralized visibility into what was out there, no inventory. And some of these solutions were actually built on top of other platforms without any consideration for that dependent platform's availability model. It was sort of a mess. So before we ever got into thinking of how we would build a solution, we sort of set out to define what we wanted in a finished product without consideration for technology or implementation details at this point. We wanted something simple and easy to use, and it had to be able to meet the demands and scale of our environment. It had to be flexible to adapt with us over time and have mechanisms to enforce best practices and guardrails. And ultimately, it had to be something that was self-serviceable by the end users. With all of that in mind, defining the desired user experience was fairly easy: simple, flexible, centralized, and a managed service. We sort of kept repeating those things to ourselves over and over again. And in the end, a platform that's easy to use, meets the needs of our teams, and is self-serviceable. We wanted there to be zero operational overhead on the development teams, and we wanted it to be managed by a group of experts. And here, I'm not just talking about experts in building a platform, but experts on gateway solutions, traffic routing patterns, and people that had a really deep understanding of the needs of our development teams. So we did what anyone does next. We assembled a sort of super group comprising of talent from our platform acceleration group, folks from our API Center for Enablement, people from our network engineering team, people from our public cloud organization, and folks from our security organization as well. And we wanted the solution to be software-based. This is something we knew up front because we needed to be scalable beyond the traditional infrastructure bounds. And ideally, we were looking at a solution that was based on the Envoy proxy, given its overall market share, the really awesome community built around it, and its API-first design. Now, while Kubernetes is our primary development platform, we still have a lot of platforms that are going to be around for a while, and this solution needs to be able to work for those as well. We needed to be able to integrate this solution with some of the existing systems for things like inventory and observability. We didn't want to have to reinvent the wheel for those sort of things. We really wanted to target solving for the greatest common denominator of our service landscape. We knew up front that it wouldn't work for everyone, at least not out of the gate. So we focused on web and API traffic first because those seemed to be the easiest to tackle and took up the largest footprint of our existing services. Overall, we knew this would be a very complex project with lots of cross-domain knowledge required for it to be successful. So we pushed for an inner-source model, making sure all of the information would be at the fingertips of any expert across the company. And again, self-service consumption was a must. Continuing to operate with the traditional cross-team ticket queue model was just not scalable anymore. So we used all of this as a criteria to evaluate several different solutions for the core data plane layer to start with. And we looked at a handful of your big box enterprise solutions. There were a number of open source projects, and we even sort of evaluated rolling our own from scratch. Ultimately, we settled on Glue Edge. Glue Edge checked almost all of the boxes for us out of the gate. And we started reaching out into the Glue community to see about some additional features that we were looking for, and ended up building a really great rapport with the folks from solo.io. Since we wanted to move very quickly on building this solution out, we partnered with solo.io to help us get up to speed and also to provide us a sort of safety net in case we ran into trouble, which was going to be inevitable with something like this. Now, beyond just Glue expertise, Solo really brought a great understanding of Kubernetes, API gateway solutions, and Envoy itself. We continue to lean on their expertise to augment our own today. Now, when it came time to actually start defining a design for what we wanted, we put a lot of smart folks together in a room and let them start whiteboarding things out. This is the high-level architecture that we decided on to essentially establish a more holistic application delivery network for our environment. At the top layer, we have perimeter controls. These are a lot of existing tools that we wanted to reuse that bring in features like monetization of partner APIs, bot detection, WAF, firewall, and other things that you typically find at the edge. Then beneath that, we have our edge gateway layer, our data plane layer, and we wanted this to handle the global resiliency, the traffic routing, the health checking, and all of the normal things of sort of the API gateway layers like circuit breaking, rate limiting, protocol translation, so on and so forth. And we refer to this layer as sort of a service mesh light, if you will. And then ultimately, we want to drive traffic back down to our platforms that are going to be in various arrays, from new platforms like Kubernetes, where we can utilize things like service mesh, and then also some of our legacy platforms like Cloud Foundry and Baremetal systems. So now I'll move on to describe how things look today. We have two major components to our edge gateway architecture: the data plane and the control plane. And Kubernetes being our primary building block for most things these days, this entire platform is built on top of Kubernetes. The data plane is just a logical layer. It's a group of Kubernetes clusters that are responsible for handling all of the aspects of traffic routing. The control plane is mainly to provide our abstraction layer and to orchestrate our end user's configuration. And we'll dig into each of these a little bit more now. So starting with the data plane for our edge gateway, it's broken up into two major components. The forwarding plane, which is responsible for attracting traffic to the data plane clusters where Envoy is running. For the GTM layer, we use a DNS-based solution that handles resolution of client requests based on a pool of virtual IPs corresponding to each data plane cluster. The GTM performs active health checks against each data plane cluster and then considers the client's geolocation to direct it to the closest healthy data plane cluster. Now, each data plane cluster in and of itself is a multi-node, highly available Kubernetes cluster where we're running Glue Edge and some other components to handle security, observability, and things of that nature. Now, one of the reasons that we built the data plane this way is so that we'd have multiple dimensions of scalability. One, we can scale up the CPU and memory resources of each Envoy proxy. Today, we're running around 2 to 4 CPUs and 2 gigs to 4 gigs of memory for each Envoy proxy. And this is specifically based on some of the benchmarking we did with a target of sustaining around 25,000 requests per second with a 0% error rate and maintaining a P90 latency under 10 milliseconds. We also have the ability to scale out the number of Envoy proxies that we have. We default to 9 replicas, that's 3 per AZ in each Kubernetes cluster, and then we let Kubernetes horizontal pod autoscaler sort of manage the replicas beyond that based on demand. Now, we also have the ability to scale out the number of data plane clusters. We run at least 1 data plane cluster per primary region, but we don't really have any major bounds on how many we can run there. It's just time and resources. Now, we also have a custom API for the data plane for maintenance purposes that gives us the ability to mark any data plane cluster as unhealthy to remove it from service. And we're in the process of testing a fully separate blue-green forwarding plane setup so we can introduce new features and perform functional testing in an out-of-band manner. Now, the control plane is a bit more complex. I'll start by answering the most common questions that I get. Isn't Glue Edge a control plane for Envoy? Why do you need a different control plane? And the short answer is yes. Glue Edge handles a lot of what we need in our environment, since at the end of the day, what we're trying to accomplish is getting the appropriate configuration to a bunch of Envoy proxies. It sort of knocks that out of the park. But we made a couple of decisions in our desired solution that Glue Edge didn't really cover, at least not then and not entirely yet. But a lot of the work that's being done with Glue Federation is very interesting to us, for sure. We wanted our Edge Gateway to work for more than just Kubernetes, and we didn't want to have the first barrier to entry for folks to be onboard to Kubernetes. The other reason were based on learnings from some of our past solutions and some of our mistakes. We didn't want to build a hard dependency on one single solution. We knew we were still going to have some other data planes in play for a while, and we wanted a control plane that could orchestrate configuration across more than just Glue Edge. So we could keep a consistent user experience for our consumers of all of our Edge Gateway solutions. We also didn't want to overwhelm our developers with having to learn anything about Envoy or Glue Edge. With our own custom configuration in play and a custom API that sits in front of Glue Edge and Envoy, we're able to decouple our configs from the data plane implementation details and limit how much config is needed for our users to get up and running. Now, how does this work? Well, we have a custom API that, again, runs on Kubernetes. And we set up this API behind the data plane itself, so it's geo-distributed. We have logic there that enables each API instance to detect what the current leader cluster is. So all incoming requests ultimately end up flowing to the leader, but any API instance can receive a request. The API handles your typical CRUD type operations for end users when they need to deploy or manipulate their configs. And we built a custom RBAC model that allows our developers to manage who has access to what, regardless of our company and team boundaries. The API handles writing the configurations to our Kubernetes clusters in the form of custom resources. And before that happens, the config is validated by a custom Kubernetes validating webhook. And this webhook handles validation of the incoming configs against defined best practices and enforces some guardrails to ultimately protect the data plane. Since this is a shared data plane, one bad config can mess up services for everybody. After that, things are handed off to our custom Kubernetes operator. And this operator has sort of three primary jobs to reconcile configurations submitted from the API. One is to replicate the incoming T-Mobile specific config to peer clusters in case there's a failure. The second piece is to translate our T-Mobile specific config into something that Glue Edge understands. And finally is to deploy the Glue configs to all the data plane clusters. This operating model makes sure that every service onboarded to the Edge Gateway platform exists on every data plane cluster. And with this, as long as we have at least one data plane cluster up and running, all of the services will still function. This is a huge improvement over many of the existing gateway solutions that we had. And it also enables another dimension of scaling out the data plane with no additional operational overhead for making sure that all the configuration gets to where it needs to be. Now, one of the first things we realized when building out an Edge Gateway platform was the fact that it was very difficult to test new enhancements. Even small config changes became fairly cumbersome due to having so many different hands all trying to work in the same environment at the same time. These environments were pretty complex. We've got multiple Kubernetes clusters for the data plane, multiple Kubernetes clusters for the control plane. So we got creative and leaned on Kind, Kubernetes and Docker. It's an open source project in the Kubernetes community that allows you to build Kubernetes clusters using Docker containers for your Kubernetes nodes rather than virtual machines or Baremetal systems. With Kind in play, we were able to mock up a completely self-contained environment that could run on our laptops where we could develop with no fear of stepping on someone else's toes. The dev environment deploys a minimum of 4 Kubernetes clusters, 2 for the data plane and 2 for the control plane. But we built in flexibility with the tooling here so you can easily adjust the number of clusters that get deployed via environment variables. The data plane clusters get all the normal components like Glue Edge installed, But one of them also has a standalone Envoy proxy with a bit of static config that acts as the GTM, so we can test certain pieces of the forwarding plane as well. The control plane clusters get our custom API, our CRDs, and the Kubernetes operator installed. And from there, we can iterate and test changes to the API, the operator, to glue, so on and so forth on the fly. We can spin up an entire test environment within a couple minutes, so there's no real fear in breaking things. We just tear it down and create another test environment. We also use this same test environment within our CI infrastructure for various control plane components so that we can perform a number of different functional tests. And we're able to do this across multiple Kubernetes versions in parallel with the flexibility of GitLab CI's matrix feature. Now, the test environment is obviously not a one-to-one exact replica of what we run in production for our edge gateway, but it's pretty dang close from a functional perspective. You want to test a new Kubernetes version? You can. You want to test a new Glue version? Absolutely. You want to test a change to Glue's config? You can. Need to get an idea of how well an enhancement to the operator is going to perform? You can. Now, next, having an edge gateway solution in place is sort of only half the battle. We also had to make it easy for other people to use. We did this by developing some usability tooling to help us and our users out. Developers can essentially bring their API definitions in the form of like a Swagger file and commit that to a source code repository where a CI/CD pipeline is going to kick off and take over from there. The API definitions are translated into configuration that our edge gateway control plane understands. And then validation is performed via a series of API calls and policy that we have in place to help lint the configuration and enforce our enterprise standards, yet again, to protect the data plane here. And then the generated configuration is then deployed out to the edge gateway control plane, where the normal process that I talked about earlier kicks off and it makes its way to our data plane clusters. And all of that information is then reported to our other systems for things like change management, inventory tracking, and compliance. One of the other great tools we have for our users is a web-based management console for our edge gateway platform. The management console acts as a read-only visualization of services on the edge gateway. Developers can come here to check compliance status, health status, the activity that each of their services have, and they can filter per environment, per team, or per individual service here. They have a lot of flexibility to get sort of ad hoc reporting and quick visualizations that everything's good and healthy. One of the other great features of the management console is that users can visualize what their services look like on the platform, what API endpoints are exposed, what authorization methods are in place, what actions are exposed, the overall compliance status. They can even manually trigger health checks, and they can view their configuration. This is extremely useful for our SRE and support teams, as it provides a mapping of services to owners to help ease coordination during incidents and triage sessions. So let's move on and talk a little about the adoption that we've seen on our Edge Gateway platform. We've been running the data plane components for the Edge Gateway in production for a little over 2 years at this point, and the control plane components have been GA since last October. There's just a small percentage of services onboarded so far, and there's still a ton of work to do, but we're seeing a return on the reduction of time developers are spending on things not related to writing code. And also seeing teams maintain a very high velocity with the self-service model. Developers can now onboard and start managing their services within a few minutes versus a couple of days to a couple of weeks with some of the previous gateway solutions. And I'm no math whiz by any means, but that, in addition to time no longer spent on non-functional requirements, is a lot of engineering hours and money saved. So let's run through these numbers real quick. So latency, we're still maintaining a P90 of under 10 milliseconds, which is great. That's a huge reduction in versus some of the existing gateway solutions we had that were running up to like 50, 60 milliseconds. We're doing about 150 million transactions a day, and we're seeing sustained request rates of around 3,000 requests per second. And during some of our major retail events, we've even seen that go up to about 5,000 requests per second. We have over 2,000 APIs and web services that have been onboarded to the platform today. And from those, we have over 14,000 different API endpoints that are being serviced. And I'm glad to say that overall, even in these early days, the project has been hugely successful. The Edge Gateway platform is now our standard platform for all new APIs. And we're taking a systematic approach to migrate off legacy gateway solutions over the next 2 years or so. Our end goal is somewhere in the neighborhood of tens of thousands of APIs and web services hosted on the Edge Gateway platform by the time that we're all done. So now I want to wrap things up by talking through some of our lessons learned throughout this project. And we'll start by process. From talking to some of our peer companies, it sounds like some of the issues we hit are not really unique to us, but our company was culturally built around one team ownership. And what I mean by that is one platform is owned and supported by one team. Now, this project touched a lot of separate teams, and ownership quickly became blurry. From our experience, I definitely recommend assessing things around how ownership is seen and handled in your organization and plan for any needed cultural shifts. The time required for this sort of thing can be really significant. And continuing along those lines with transparency across teams, the inner source model really helped us to achieve full transparency during the design and build phases of this project. Taking notes in all meetings to track design decisions, architectural requirements, so on and so forth, proved to be extremely useful. All information was in a centralized place with all teams having equal access to read and contribute along with peer review. It gave everyone a sense of ownership and the ability to prioritize what was important to them. And this was especially helpful given that a platform like this can be seen as displacing some existing teams. It's very important to emphasize the displacement of tools and not people. Moving on to the area of design, make sure you give yourself enough time to plan for abstractions. Abstractions are hard, and you shouldn't just do them without good reason. Talk through them over and over again, weigh the risk versus reward. For us, we were looking at the existing tools our users had, what configs those exposed, as well as what config new tools like Glue exposed. We spent a lot of time trying to nail down what the abstraction for all of this would look like. And ultimately, I feel like we still should have spent even more time on it. Now, if you decided to go the path of an abstraction, you also need to decide how much to abstract. And that goes hand in hand with some of the guardrails that I want to talk about next. In our project, we chose to build an abstraction on top of some existing technologies and tools. And that meant we had to know that our abstraction plays nice with things like Glue and Envoy. We started with some very simple validation up front on the config that was essentially input to our platform, and quickly learned that it was very easy to have bad configs submitted that would cause issues with the pieces underneath our abstraction. And in hindsight, we should have planned for more in-depth validation of the config on day one. Now, as with any abstraction, one of the main goals should be to reduce the cognitive overhead on the consumers of the platform. Here, I'd recommend you err on the side of exposing just enough config and balance the footprint of your abstraction and the complexity you expose to the end users. If you start to approach a one-for-one copy of the underlying technologies in your abstraction, you're probably doing it wrong. The abstraction layer allows us to infer a lot of config that we can template and never have to expose to the end users. And that's something very important to consider. Moving on to the area of unplanned, the unknown unknown. One of the first things we hit in this category was scaling issues. Scale is a very weird thing. Every environment's different and every tool or technology can be different. Plan for this sort of thing in your timeline. We hit a few different issues on scalability with our custom orchestration engine and also with Blue Edge itself. I definitely recommend spending some time to consider scale up front. If you're consuming an open source project as part of your stack, reach out to the community and ask about what scale the project has been tested against. This is where our partnership with solo.io saved us a ton of effort and heartache. Whether it was leaning on their deep understanding of Envoy internals in the early days, or having help to validate some of these scalability issues, or adding new features upstream to solve for some of these problems. And then last, but certainly not least, hybrid cloud is tough. Our initial goal was one edge gateway to rule them all, spreading a single solution across both private and public cloud. And we quickly found out that doing that without introducing cross dependencies on either side is pretty dang hard. We ended up adjusting our goals for the platform and decided to treat public and private clouds as separate edges. And rather than seeing that as a defeat, we just chose to spend the time getting a solution out the door. And I can't emphasize that enough. We made sure that we were tracking further R&D to make things happen later with this. And I say that to remind folks that it's perfectly okay to not get everything right in the initial design. Be flexible and don't give yourself a hard time. Now, thank you all for coming to my session today. I really appreciate the opportunity to share our journey with deploying an edge gateway solution. A huge thanks to solo.io for hosting, and thanks to all of the awesome folks that I get to work with at T-Mobile to build cool stuff like this. Now, provided I didn't talk too much, I think we might have time for some questions.